Now I want to talk about the human eye. Human eye is a fascinating thing. And if you think of the structure of the human eye, you've got a bunch of different parts. The retina is your screen, the projection screen. This has got all the little sensors. They're little sensors, and each sensor says, what color am I seeing? And it sends that information through nerves to the brain. An interesting thing about the retina is you got to get all those nerves out. And there's this little area here where there's no screen, there's no retina, because the nerve is passing through there. That's called the blind spot. I'll talk about that in a second. There's a cool demonstration with that we're going to do. Um, Over here in the front, this whole structure is called the lens. The iris is a little muscle that lets more or less light in. Okay, so if you wake up in the middle of the night and you look at somebody's eyes, this is much wider because it's trying to let more light in. It needs more information. The sensors aren't sensitive enough if this is closed. As this opens up more light comes in, but if you think of having and we talked about this before, but if you think of light from this spot right here, I don't know why I can't draw on this. There we go. If we have light from a spot right here coming over here, but there's also light from here coming to that same spot. And if those two different color lights are different, you're going to get this blurring on the back there. So what the lens does is it focuses the light just according to the kind of rules we learned with ray diagrams. I'm going to show you that. All this stuff is goopy. Even though we just call this little piece the lens, all of this refracts light. The muscles on the side here and down here flatten or relax the curvature there, so it changes the focal point, the focal length. Let's take a look at the blind spot. This is kind of cool. I have no idea what these lines are. They just kind of showed up, and I can't get rid of them. Can't seem to get rid of them. So for blind spot, remember I said that there's one spot on your retina where light you can't detect the light. There's no sensors back there. And here's how to check that. What I want you to do is look at this spot right here. I want you to close your right eye, and then with your left eye, look at that spot. Then move closer and closer and closer to the screen. Don't ever look directly at this. Just be aware that it's there. You can tell there's another dot there. And when you get about 3 or 4 inches away, this dot will disappear. You won't be able to see it anymore. I'll give you a few seconds to do that. So you're leaning in, leaning in, leaning in, and eventually that dot disappears. Well, that's kind of weird. And let me try something different here. I didn't even think of doing this, but I'm going to try this. Let me try changing the background. Let's set the background fill to, I don't know, let's make it teal or cyan or something like that. If you do the same experiment, hey, lo and behold, that hole there, it's not black, it's not white, now it's teal. And that's because your brain fills in the information. It says all the sensors near the blind spot are seeing this color, so let's just pretend that there's that color there. It's a good feature because it keeps you from having black spots in your vision all the time. Whoop. Okay, so normal vision, if you have a good-looking guy like our principal, and you're looking at him, and we think of that ray diagram, there will be an image formed, a real inverted image formed on the back there. And if your vision's good, great. If you're a little off, these muscles will change the curvature a little bit. You're not even conscious you're doing it. But if you think of looking at your finger when it's 2 inches in front of your face and then looking at something in the distance, you can sort of feel that your eye is changing the curvature. It's straining a little more or less. So that's normal vision. Here's my vision. My vision, I look at Dr. Wilmore, and there's a perfect image, but it's in the middle of my eyeball where I got no sensors. So if I have no sensors there, I can't detect this perfect image. And my eye muscles will strain and strain, and it'll move it in and out a little, but it can't produce a beautiful image on the back. So what's happening there is, if you look at any spot here, the light that's coming to there is coming from multiple places over there. If you have perfect vision, the light from the very corner of his eye is going to go to one spot there, and only that light is going to arrive there, and so that's called clear vision. I have blurry vision because these rays spread out. So theoretically, since my eye can't adjust, I need contacts. In contacts, a diverging lens spreads out the rays and makes the light come together a little farther back. It's a little more complicated. They have biconcave, biconvex, concave, convex. There are all these combinations, and but the basic concept is that I have a mildly diverging lens, a mildly concave lens that spreads out the rays and projects perfectly on the back. With my really bad eye that I had the eye injury to and that I still have some issues with, what happens is, wow, I don't know why I did that, but let's go with it, is on my cornea right here, I scratched my cornea. I actually had a big cut down my cornea, and when it healed, if we're looking head on at the cornea, I had this line like that that kept ripping apart. So what they did is they scraped away all of the outer layer called the epithelium and then let it all grow back into the middle. And one of the problems I had right after it grew back in the middle was I had this really irregular stuff in there. And so the rays that were coming in were going in all different sorts of directions. And so I couldn't really see very well out of that eye. It seems to be better now. So I'm hoping that I'm back to a correctable eye problem. And that's it for lenses.